All right, welcome back. This is ionic compound naming or nomenclature from formulas. Okay, so over here I have some things you need to keep in mind as you're trying to do these. Okay, so when you come to class, I want you to have all of my examples and some things that you're supposed to look for, and any questions you have regarding ionic compound naming from formulas. Okay, so first thing you need to look for is transition metals. Remember, they need a Roman numeral. All transition metals need Roman numerals except for silver, cadmium, zinc, aluminum, gallium, and indium. This does include the ones that are next to the metalloids that we that we colored black on our periodic table. All polyatomics keep their name. Okay, all polyatomic ions keep their name. So if they're on the back of your periodic table and they're in a formula, they keep their name. All metals keep their name. The only thing that we change on metals is if it's a transition metal, we give it a Roman numeral. Non-metals, if they're in the anions, change their name to their ion name, which has the IDE ending. Okay? So let's get started. We have CaSO4. Well, I know that I have more than 2 elements in there, so I have to have a polyatomic ion. It's not going to be calcium, because calcium's on my periodic table. It's the SO4. So if I go to the polyatomic ion chart on the back of my periodic table, then I will find that SO4 is sulfate. And I'm going to just write it down, because polyatomic ions keep their name. Okay? Now I have to see if calcium is a transition metal. If I look on my periodic table, calcium is in the alkali metals. It's in column 2, so it's not a transition metal. So it keeps its name. And we have calcium sulfate. And that's it. That's how you say that formula, calcium sulfate. Let's try the next one, Na3PO4. Again, I have more than 2 elements attached to this. So I'm going to have to go look for a polyatomic ion. Well, I know it's not sodium, because sodium's on my periodic table. It's got to be the PO4. You go and look on the back of your periodic table, and you see that it's phosphate. And I'm going to just write it down, because it says polyatomics keep their name. All polyatomics keep their name. Sodium, is it a transition metal? No, it's in column 1. Sodium phosphate. Okay? So now let's look at the next one. Again, I have a polyatomic ion. So I'm looking at it, and I know that it's in a parenthesis, so that tells me what my polyatomic ion is. So I'll go and look on my chart, and I find out that it's nitrate. And I write it down, because all polyatomics keep their name. I look and I see Fe. I know Fe is iron. Is it a transition metal? Well, it's right in the middle of my periodic table, so yeah, it is. It's not one of my exceptions. It's not silver, cadmium, zinc, aluminum, gallium, or indium, so it needs a Roman numeral. So I'm going to go ahead and put a parenthesis here. Okay? How do I figure out what the Roman numeral is? This is going to take a little bit of work. Okay? This is where you're going to have some work on here. So if you remember from earlier, when we took names to formulas, and we had something here, well, you just do the reverse. So I have iron, and then I have NO3, and I have a 2 down here. Okay, NO3, and I have a 2 down here. Well, what would happen to this 2? Well, what would have to be here? This is where we have to figure out what's going on. Well, I know that the original oxidation number for nitrate was a negative. Well, that matches, because if I put a negative down here, this is what I would have gotten rid of. So what do I do with this 2? Well, if I put a plus sign on it, I'm going to reverse it and put it back up here. Okay? So I'm basically doing the reverse crisscross. I'm doing the opposite of what I did to find the formula to find the name. Okay? So here is what goes here. The 2. Okay? It's iron 2 nitrate. Iron 2 nitrate. So reverse crisscross. Okay? So If you're having trouble with this, come to class and I will explain it some more. Okay, I will get it to you some more in class. It's really, once you get it, it's not super hard. It's hard to figure out at first because you're doing the opposite of what you're used to doing. And so we'll do a couple more of these. Okay. So let's look at the next one, PB3PO4. Well, PO4 is on my poly chart, so I'm going to go ahead and put phosphate. Because I'm going to go look at it, and there it is, phosphate. And then I have lead. I know PB is lead. It is in the transition metals. Even though it's black, we put it in the transition metals because it's a metal. It's not one that it's not one of the ones that has a permanent oxidation number. So again, we have to do the reverse crisscross. The reverse crisscross. Okay? So I don't think I reduced anything. So I'm going to go ahead and put my plus signs back on and my negative signs back on. Okay? I don't think I had to reduce anything because if I go look at the polyatomic ion chart, this PO4 had a 3 negative. Okay? So we're going to put it back up in the top. So what has to be here? Well, if I have to reverse it, it's going to be a 2 plus. Okay? And this 2 plus tells us what goes here. And I have lead 2 phosphate. Okay? I'm just doing the opposite of what I did before. I'm going to reverse it. Where you have to be careful is if you have any reductions. Okay? So, and we're going to practice those in class. And so that way you can see it. And I have an activity so you can see it as well. Okay? So let's take this next one. NH3Cl. Well, I have more than 2 elements in there, so I know I have a polyatomic. It's not H3Cl. I can't find that anywhere. It's not Cl, so it has to be NH3. Well, this one is going to be your ammonium. And it's going to keep its name. Now I have chlorine. Well, it's not a metal. It's an anion. It's not on the polyatomic ion chart, so I have to go back to its ending for an ion. Well, I know that chlorine is a nonmetal, so I'm going to change the ending to IDE, so I end up with chloride. Ammonium chloride. Okay? We took the INE off and put IDE. All right, this last one we have is AgOH. I know I'm going to have a polyatomic ion because I have more than 2. It's not AgO. I can't find that anywhere. Maybe it's OH. Oh, look, there it is right there. Hydroxide. Hydroxide. Okay. So now it's going to keep its name, so I write it down. Now I have to write down Ag. I go and look on it. It's silver. It is a transition metal. However, it's also one of my exceptions. One of the ones that does not get a Roman numeral because it always has a +1 charge. And we wrote it on our periodic table. So it's just silver hydroxide. Okay? Let me erase this. You can fast forward while I erase this. And we're going to do one more. All right. I think that's about... Okay, I think that's about good. Okay, so let's do one more. Let's do CAF. CAF, okay? I only have how many elements in here? Just 2. So I'm not going to have a polyatomic ion. So I don't know I just have to go find my elements. So there's calcium. And calcium is a metal, so it's going to keep its name. Here's fluorine, and it's a nonmetal, so it's an anion. It's going to change it. Fluoride. Fluoride. Okay? Calcium fluoride. If you only have 2 elements, it's a binary compound. and you just look at your metals, keep in the name, and your nonmetals are going to change to IDE. So it just would be the metals plus a nonmetal, and you put your ions together. Your names for your ions. Just take the word ion off of it. Calcium ion would become calcium. Fluoride ion would become fluoride. Calcium, fluoride. Okay? I'll see you on the next video. You guys have a good night.